Today we're going to be talking about the area between two curves, but yesterday I gave you what the graphs looked like. Today you're going to have to come up with the graphs, and that's a little bit more challenging of a concept for a lot of guys to work with. So the first one, x minus y equals 4. So what I'm going to do real quick, I'm just going to do intercepts. If I get my y-intercept, that's equal to negative 4. My x-intercept is a positive 4. You could put in y equals mx plus b if you're more comfortable with that. So that's one of our curves. Now the other one, okay, technically that's a parabola. If you don't recognize that it's a parabola, that's okay. It's actually technically, since it's a y squared, it's a parabola that looks like that. It's not translated up or down any, but that vertex right there is sitting on our x-axis. That vertex right there is technically, if I factor out the 2, that's 7/2. Okay, so it's a parabola. Vertex is negative 7/2, which is 3.5, 0. And we have, that's what that curve looks like. You have to find those two intersection points. Okay, sometimes they're going to make you guys find those two intersection points by hand. Sometimes you're going to have to use your calculator. So what I do to find the two intersection points is I am going to take it, I'm going to substitute in x equals 4 plus y in for x in the other equation. So I have y squared minus 2, 4 plus y equals 7. We get y squared minus 2y minus 15 equals 0 when I go through and simplify that. So we have plus 3, y minus 5 equals 0. So our y intersection points are from negative 3 to 5. Now you have to determine whether it's easier to integrate with respect to x or with respect to y. If you're integrating with respect to x, you'd have to break it up into two areas. You'd have to break it up here along where that intersection point, where it changes from our y equals x squared, or our y squared function, to two different functions. But if you look at it like this, when you draw a line, you're always going to have one function to the right of another function. Okay, so we're going to find our integral from negative 3 to 5 of the function that's to the right, all in terms of y. So that function that's to the right, all in terms of y, meaning I get it x equals, that's x equals 4 plus y. So I take the function that's to the right, 4 plus y, minus the function that's to the left. Now I need to get that all in terms of y. Also, this function, all in terms of y, which means x equals, is y squared minus 7 over 2. So I have minus y squared minus 7 over 2. And this is going to be in terms of dy. So simplifying that integral, we get y minus y squared over 2 plus 15 over 2. That was just simplifying everything out. I take my integral, and my integral is 15 over 2y plus 1/2 y squared minus 1/6 y to the third evaluating from -3 to 5, plugging in values, and I'm not going to lie, I used my calculator on this because of all those crazy fractions. I got 128/3. Okay, finding the area between those two curves. So we have 1, y equals x squared minus 4x. If I factor out an x, we get x minus 4, so 0, and 1, 2, 3, 4. That's a parabola facing up. Okay, the next one, if I factor out an x, we have negative x plus 6 so our x-intercepts are 0 and 6 now, but with this negative, with the negative out front, remember that means we're facing down. Okay, so we have one intersection point at 0. We have to find this other intersection point. So I set the two equations equal to each other. Set negative x squared plus 6x equal to our x squared minus 4x. Going through and solving, getting one side to 0, I get 2x squared minus 10x equals 0. I factor out a 2x. So I get x equals 0 and 5. So what we're going to have to do is we're going to have to take our integral from 0 to 5, and we're finding this area. Luckily, one function's always above the other one. Our purple function, negative x squared plus 6x, then I have to remember to subtract. The other one, which is x squared minus 4x dx. Okay, so then from here, I take my integral and I simplify. First I simplify to get negative 2x squared plus 10x dx. I take my integral to get negative 2/3 x to the third plus 5x squared from 0 to 5. And when I plug in and evaluate, I get 125/3. Okay, the next example that I have for you guys. Find the area in the first quadrant, so that's why I have my first quadrant, bounded by the line y equals 5x. So that's a pretty steep sloping line. X equals 5. That is a straight up vertical line. And y equals 5/x squared. Actually, let's do that one in red. Y equals 5/x squared. Well, that's going to be a function that looks something like that. So what I'm looking for is I'm looking for this area. Notice one thing here. Lots of colors today. At that value, when those two functions intersect at that value, your functions change from to the left of that from 0 to whatever that value is. All you're finding the integral of is the area under the curve of 5x. Then we're going to add to that the integral from whatever that value is to whatever this intersection point. Well, we know that's a 5 because I have the line y equals 5. I'm sorry, x equals 5 of now just our 5/x squared function. So we need to find this intersection point. Well, that intersection point is where 5x equals 5 over x squared. Multiply both sides. So when x cubed equals 1, so that's when x equals 1. So that's what we're going to be putting there. We're going to be putting a 1 there and a 1 there. Okay. So now, we take the integral of that. That's 5 halves x squared from 0 to 1 plus 5 over x squared. My new exponent is x to the negative first. So you need to remember that that's going to change that sign to a minus because you do 1 over that exponent evaluated from 1 to 5. Now plugging in all of that, plugging in our values, we get 13 over 2. And that's it in getting our graphs for today. Please make sure for me that your lesson summary is submitted on time.